Hello everyone. Today we're going to talk about some commands that can let you to manipulate files content. So our first command to be introduced is a cat. I think you guys have already familiar with the cat command because we have used this multiple times before. So basically the cat command can display the content of the files in the screen. Okay. So when cat is run without command line arguments, say we just directly type cat in the terminal and run it without any arguments, it will take its input by default from the keyboard. It will echo each line that is typed by the user until they decide to quit by typing the control key and C key together at the same time. So basically, if you just run cat by itself without any arguments, without any file's name here, and after you run this cat and whatever you type, it will display the same string after you finish typing. And then if you want to quit the command, you just you just press Control key at the same time, and it will let you to go back to the terminal. The default behavior is not interesting by itself, but what if the standard output of a cat is redirected? So if its results are redirected to a file, nothing will be displayed on screen other than what is literally typed as input until it is quit. Whatever is typed to that file can can then be examined by the user by quickly using cat again. So recall that cat has other important uses, particularly with the I/O redirection. If you remember, there are primarily two shell operators for input redirection: the single less than character and a double less than characters. So the first one will let you to redirect a file as the argument for a command, and the second one for here documents as an input string for a command. Another kind of input redirection related to here documents does exist, known as here strings, where the ordinary string is used, not a specialized string. The operator appears very similar to the one used for here documents. So in here we just use 3 less than characters. Okay. For example, here are some examples of these 3 less than characters. The third one, the grape example, is by using these 3 less than characters, it will let you to find the same substring in this long string. Okay, and then it will give you the number of this substring. For example, in here, this substring only appears just one time in this long string, so it will give you number 1 here. And if you remember, here are actually 3 shell operators a user can utilize when they are redirecting the output of a command. For example, the first greater than, and this one greater than character will redirect to a new file that does not exist, and the double greater than characters will append to a file, and a vertical bar means to pipe to another command as part of a command pipeline. The most common operation to see in the bash shell script is the usage of command pipes, also known as just pipelines or paps. The end of a pipeline will place the final result for the overall command composition to either the standard output or to an output file. Recall the assignment of command outputs to a variable by using substitution. In essence, the backtick quotes, also called back quotes in bash, can be considered somewhat as redirection in the context of what they do. After bash executes whatever commands are contained within the backquote, it replaces the command substitution with the standard output of the executed command. In other words, the command with the backquotes is the same as the dollar symbol and parentheses in the command. The pipe operator represented with the vertical bar character connects the output of the previous command named on the left of it to become the input of the command on the right of it. So therefore, the command can be composed upon each other to create an advanced commands using the pipes. For example, here, by executing this command, it will give you the real names of everyone with an account on the computer. So let's explain this command. So basically, the first command, this command, will give you the whole information shown in the password file. And basically, this information can contain like the everyone's username and everyone's real name, and like the passwords and their other informations. And this whole information will be the input of the next command. And this AWK, once the AWK command receives the output from the previous command, it will slice the information into several different columns. For example, the first column will be the user's username, and the second column could be the user's like the terminals numbers, and so on. And in here we print the fifth column, which is the real names of everyone with an account on the computer. Okay. And a pipe was demonstrated in the first unit of our class. If you remember, in our previous class, we used this command to print the list of usernames of people currently logged in one per line. Okay, so here the who command will give you the names of all users, the whole information of all users currently logged in, and this whole information, this completed information will be input to the next command, this AWK command, and it will give you the separated informations by different columns. And here we only print the first column, which is the usernames, and then by the sort command, it will sort the usernames by their ASCII2 characters, which will be introduced later, and then by the unique command, it will remove those duplicated names. So this result of this pipeline is a list of usernames of people currently logged in one per line. Okay. And actually, when you just want to check this kind of information, you don't have to type this long commands. You just use this users command, a simple short command, and it will also create this list. Okay. So this AWK, the sort, the unit, actually these commands we call that filters. And these commands are examples of a class of Unix programs. And a filter here is a concept of a filter. So basically, it's a kind of Unix command whose input and output are ordinary text, and that expects its input from standard input and output their output on the standard output. So filters transform their input in some way, like sorting this or removing some words or lines based on a specific pattern. For example, if I want to remove search and remove the lines whose contain apple, or their position in the line or file. For example, remove every third word in the line or remove every fourth word in the line. Okay. And filters may have files named arguments on the command line, but when they have no such argument, say we just have this filter itself, they will read from standard input, like defaulting to the keyboard instead. For example, if you just have the a single filter command and there's no arguments, and here once you type your keyboard to input something, and this string you just typed will be considered as a input of the command, of the filter command. Okay. So for example, if it is completely forgotten for the grep command, it will return an output call when searching for the pattern of a clue based on what is typed by the user. Whereas it is, if it is given something that appears to be a file, as shown in this pipe example for a file called text file. And for example, this one. This command will search through the standard input stream and searching for any lines containing the pattern a clue. Okay, so basically this text file will output the text file's content, and this content will be considered as the input of this grep, and this grep will receive the content of this text file and start to search the a clue in this text file and see if it has the include or not. And here the explanation of the filter commands, some common useful filter commands. You don't have to remember all of it, but we will introduce some of them later. Okay. And some filter commands execute based on arguments given as a specific text pattern arrangement. For example, in our previous command, we use the grep to search the pattern, which is called a clue. Okay, and this pattern arrangement is called regular expressions. Okay, and this particular patterns of text use certain characters to represent different things. The most common command that uses regular expression is naturally grep. Otherwise, certain filter commands do not require patterns as arguments to execute. Rather, those filter commands have their own default arrangements to be filters. The sort filter is used for sorting the lines of one or more text file in the sequence. As a command, it will print to standard output, typically to the terminal shell, and the simplest form is like this: sort and the file's name that you want to sort. This command will sort the lines in the file name using the first field of the line, which is the first set of characters leading up to the first place before the next field. Sort will ignore case sensitivity in some versions of Unix. However, this is now the Unix versions, so probably in other Unix versions, the uppercase and lowercase letters will be treated as different characters. So which means if you want to use the sort by ignoring the case sensitivity in the Unix operating system, you need to check if in this version the sort will ignore it by default or not. So the default sort pattern is the F2 collating order. It treats them like letters based on the F2 standard code order. So it means that the sort command will not sort numbers in the numerical order. For example, if the file named source contains the following lines like 5, 11, and 10, and this sort command will not treat these numbers as a number by default. Instead, it will treat these numbers as strings. So if it is strings, then obviously the string containing number 1 will be let's say will be in the first order. Then the string contains number 5. So which means the number 5 string will be followed by the number 1 string. Okay, so if you directly use a sort command without any flags to sort the scores file, I will give you this output, because this output, this order is not followed by the actual number. It is considered the numbers as strings. So in the string, the 10 and 11 and 5 will be listed like this order. Okay. However, if you want to use the sort to sort some numbers, say here. Say if you want to sort those numbers as number 5, number 10, number 11, and obviously the number 5 will be the first place, and the second one will be the 10, and third one will be the 11. You need to add a small n flag, and with this flag, the sort command will consider the content as numbers. So I will sort the output by increasing numerical value. And if you want to sort it in the reverse version, say from the largest to the smallest, and with this number, with the small n flags, you need to add another flag and small r here, and which means the reversion. So with this flag, it will output the reversed order of these 3 numbers. And another flag in the sort command is called is the small key, and the small key flag can be used to sort by fields. So the set of characters delimited by any amount of space before the next field in each line. The fields are accessed as numbers read from left to right at field key number 1 to the last field at field number n. Sorting can be based only the second field or only the third field, like the following 2 commands. So for example, if you use the small key as the flag in the sort, and with this 2 here, with a number here, so in this case, this command means you will sort the field, you will sort the file by the second field. Okay. And to use the second field as the primary key and then the first field as the secondary key, and here is a command. So we first use type number 2 here, means we use the second field as primary key, and then with the commas, and then the number 1 here means use the secondary key, use the first field as the secondary key. Okay. And another useful filter is called unique. This unique command will remove a line from a file if it is identical to the line preceding it. So if a file that has duplicated lines, then the output is piped to unique. So all those duplicated lines will be removed. And this unique command is seen by using the small u option with a sort. So this is not why the unique is unique. So sometimes there are files that are not sorted but have ranks of the same lines, such as data containing several lines of various DNA sequence. So depending on the contents and context of the file, it might be appropriate to use the unique instead of sort with a flag small u here, because maybe you do not want to sort it. Okay. And here is another filter command called fold, and this fold command will break each line to multiple lines of a fixed number of characters, number n here, for example, with the width small w flag, so that each line is at most a certain length of characters. For example, if a file called DNA and it contains two lines, the first one, the second one, and if you use this fold with the flag small w and with the number 4 here, and in this case, it means you break those two lines into several different lines, and each line at most have 4 characters. So here is the output of this file. What if you need to get a specific set of characters regardless of space? The best time to use the cut command is when working with a database-like file, where there is a delimiter that separates each file of data. For example, consider the password file we have already learned before. And this password file contains a lot of information about each user and one user per line, right? So each field is delimited by the column here. So to produce a list of username that appears in, we can report only the 5th field by using the cut command. So the delimiter is literally specified by this small d flag, and the field is reported with this field flag. Okay, so in here the delimiter is column, and we want to report the 5th field in here. So this command will only output the 5th field with this password, and each field is separated with a comma, with a column, with other two other different fields. A common task for pipelines is to change all uppercase letters to lowercase, or vice versa. So luckily, the tr command will make this easy by doing a one-to-one match of what it takes as its first argument with whatever is specified as the second argument. Okay. So for example, in this case, this tr command will have 2 arguments, and in this case, it means you can convert the lowercase letters to the uppercase letters. Okay. If you know how cat works, then you mostly already know how tag actually work. So you can see the tag actually is the reverse characters of this cat. Okay, so basically, this tag will give you the reversed version, the reverse output of the cat. And here are the examples. It is pretty straightforward. So there are times when it is useful, but it's not necessary, like when a command may have a reverse option already. For example, the sort command. Like we sort a list of numbers from smallest to the largest, and we can use the small r as the flag, and with this small r flag, the sort will give you the reversed version. Note that it will not reverse the characters in each line of the file. So look up the reverse command and use that in a pipe to generate a reversed and backward version of the file content as output. And here is another easy command called WC, which is stand for the word count. So by default, it will display the numbers of lines, words, and characters in one or more files that are given as arguments. So for example, in here, with this WC command, and if you want to count how many words in this file, you can use this WC command, and it will give you, say, 23,127 characters in this in this specific file. Okay, and their first output is the number of lines, and second one is the number of words, and the third one is the characters. Okay. If you only want to display for example, the number of lines, and if you do not want to display all of these three informations, you can just specify the arguments, the flags. For example, if you only want to display the number of lines, you can use this small l as the flag, with the WC command. Okay, and in here it will display the number of users currently logged in. So, for example, in another one, it will display how many people are currently running bash at the time of execution. Because the WC here will display how many lines of the information of the content, and this who command will give you the information about the users, and each user is occupied one line. So by this pipe, by this vertical bar, by this pipe character, it will transfer the output of who to the WC command, and the WC command with this small l here will count how many lines of this who output. Okay, so which is equivalent to how many users currently logged in. So here is our class today, and don't forget to finish the quiz number 4, and don't forget to finish our assignment. So that's it.